Welcome back, mathematicians. Today we're starting one of the most important topics in high school math, trigonometry. Trigonometry is just the study of triangles, and we'll focus on right triangles. There are three special ratios that connect the sides of a right triangle to its angles: sine, cosine, and tangent. In this lesson, we'll start by defining these ratios. Then we'll practice using each one, sine, cosine, and tangent, to find missing sides of a triangle. After that, we'll flip the process around and use them in reverse to find missing angles. By the end, you'll be able to handle any right triangle problem by deciding whether to use sine, cosine, or tangent, and knowing exactly how to set it up on your calculator. Let's start by looking at what a right triangle looks like and this acronym SOHCAHTOA that can be incredibly helpful. So first of all, remember from geometry, a right triangle has a 90-degree angle. The sides that are attached to the 90-degree angle are called legs, and the side that is opposite the 90-degree angle is called the hypotenuse. It's really important to have that terminology memorized before we start talking about the three trig ratios. The first trig function is sine. We spell sine like this, but we abbreviate it like this. We don't pronounce it sin. That's a common mistake that a lot of my students do. We do still pronounce it as sine. The second trig function is cosine, and we abbreviate it like this. And the last trig function is tangent, and we abbreviate it like this. Now, each one of these has a special relationship with the right triangle. You can find missing sides and missing angles by setting up the relationship as ratios. So we're going to look at each one of these individually. Let's start with sine. Sine can be found by finding the ratio of the opposite over the hypotenuse. We often don't write these words out entirely. We write them as OPP over HYP, and you might notice the first part of the acronym kind of looks familiar if you think about the first letter of every part of this relationship. The S does stand for sine, the O stands for opposite, and the H stands for hypotenuse. So the SO in SOHCAHTOA tells you how to set up the sine ratio. Cosine is adjacent over hypotenuse. And finally, tangent is opposite over adjacent. Now I'm going to shrink these up a bit so that we have a little bit of extra room and put them down here, because we're going to look at what each of these ratios looks like with the value that we have on this particular right triangle. So let's start with the SO. Sine equals opposite over hypotenuse. So we would say the sine, and we have to orient ourselves to one of the angles. So we're going to call this angle A and this angle B. Depending on which angle we orient to, our sine ratio is going to be different because it says it's opposite to the angle over the hypotenuse. So if we're talking about sine of the angle A, The opposite number is 5. This is the side that is opposite of A. We can draw a line straight to that 5. The hypotenuse doesn't change. It's always going to be 13. However, if we want to find angle B, opposite to angle B is 12. So we're going to put 12 over 13. And that's how we find the sine ratio for each of these. Now let's find cosine. Cosine is adjacent over hypotenuse. So if this is the angle that we're orienting to, adjacent means right next to it. So this one is going to be 12 over 13. And the cosine of B, right next to B, is 5. So this is going to be 5 over 13. Finally, let's work with tangent. Remember that tangent, the TOA part of SOHCAHTOA, is opposite over adjacent. It doesn't use the hypotenuse at all. And again, you have to orient to the angle that you're using. So the tangent of angle A is going to be opposite, so that's right across from it, over the adjacent number, the one right next to it, 5 over 12. Let's clean this up a little bit so that we can orient to angle B. Tangent of B, then, is opposite, which is 12, over adjacent, which is 5. Notice that these are reciprocals of each other. Let's go ahead and put these trig ratios to work. In this example, we have an angle 35. I like to tell my students to always orient to that angle. If you're working on a piece of paper, it's helpful to have a highlighter and to go ahead and highlight the angle that you're oriented to. That way, we can identify what is the other information that we're being given. So we're being given the hypotenuse. So I'm going to label this hypotenuse. And we're also being given the adjacent. So I'm labeling this adjacent. Since I have the hypotenuse and the adjacent, that's how I know to use cosine. Cosine is going to be of 35 degrees, like this. And I'm going to set up this ratio with adjacent over hypotenuse. So it's equal to x over 12. All we have to do now is solve a one-step equation in order to find x. Remember that if you have something in the denominator, you can remove it from the x by multiplying it to the other side. When you multiply it to its own side, it cancels. So we're going to multiply it over here. That gives us that x equals 12 cosine of 35. Now, some teachers might want you to stop here. I'm also going to teach you how to put this into a calculator. It's very helpful to have your own graphing calculator, especially by the time that you're in trigonometry or pre-calculus. But if you're watching this video as a geometry student, I would definitely go ahead and get a graphing calculator as well. I've had my graphing calculator since high school. It's still super useful. They don't update them too much. And so it's not like buying a computer and you have to update that computer every 5 or 6 years, some people every 2 or 3. This will last you for a very long time. It will definitely last you the rest of high school, and it will probably also last you the rest of college if you're going to college. If you don't have a graphing calculator, that's okay, because Google Calculator has a great one. So just type in Google Calculator into the Google search bar and it'll bring it up. Now you need to make sure that you're finding the trig functions, sine, cosine, and tangent. They're going to look like this. And as you might guess, we're going to use the cosine button. But I want you to check one more thing. I want you to make sure that the calculator is in degrees mode. Since we're working with right triangles that are in degrees, we are not working on radians. Radians, just to give you a little sneak preview, is when we express in pi. But we're using degrees. The Google Calculator has a little toggle switch to go back and forth between degrees and radians. For most graphing calculators, you can find this under the Mode button. But since every calculator is just a little bit different, you might want to look at your manual, which is very confusing. So I highly recommend just searching on Google again for how to change to degree mode and then type in the type of calculator that you have. Once we have it in degree mode, we're ready to go ahead and put this straight into our calculator. So we're going to type 12 times, hit the cosine button, 35. When we do this, we get the number 9.82982 and on, and that is very normal. I'm going to round it to the nearest tenths. Since it was followed by a 2, the 2 doesn't change the 8, and so I can leave it at tenths. Now remember that what I was finding was a side length. So I want to come back over here and check for the reasonableness of my answer. With a hypotenuse of 12, it's very possible that my side length could be something like 9.8. Let's move on to finding another side using a different trig function. Remember that the first thing we're always going to do when we tackle these problems is to orient ourselves to the degrees. Here's where our degrees are. And so we're going to check what are we actually given so that we can pick which one of these SOHCAHTOA to use. We have a missing value across or opposite from the degrees. And of course, we're being given, again, the hypotenuse. That means we have an opposite and a hypotenuse, and therefore we need to use sine. Since sine is opposite over hypotenuse, I am going to use the sine of 40 is equal to x over 12. Just like the last example, in order to solve this, I simply need to multiply 12 to the other side. That gives me x equals 12 sine 40. Now you should still have your calculator in degree mode, but if you get something funny, chances are you don't have it in degree mode, and you should check. When I plug this into my calculator, I get 7.713, on and on and on. I like to round these to tenths. Lots of instructions will tell you that as well. Since it was a 1, it's not going to change that 7, and my side length is 7.7. That's very reasonable considering a hypotenuse of 12. So I've also checked the reasonableness of my answer. Finally, let's do one more where we're not being given the hypotenuse. We're still going to orient to where the degrees are though, and we're going to look to see what we're being given. Remember that if we're given something that's right next to the degrees, it's adjacent. And if it's opposite the degrees, it's opposite. Since we're being given an opposite and an adjacent, that's how we know we're going to use tangent. So I'm going to set up my ratio using the tangent of 30 is equal to the opposite over the adjacent, x over 10. This is the same process of multiplying the other side by 10 in order to get rid of the denominator. When I put this into my calculator, I get 5.7735 and so on. Again, I'm going to round that to tenths place, but the 7 is big this time, so it's going to change it to 5.8. So now we've learned how to use sine, cosine, and tangent in order to find missing sides, but what do we do if we don't have an angle? So now we've learned how to use sine, cosine, and tangent to find missing sides, but what do we do if we have a missing angle? Missing angles are set up in a very similar way to missing sides. We are still going to start off with orienting ourselves to the degree. Then we're going to figure out what we've been given. In this case, we've been given something that is adjacent and something that's opposite. So I know I'm going to use tangent. But I don't have the degrees here. So we can use theta as our variable. We could also write this, and you will often see this written as tangent x. Either way, these are just two different variables. I'm going to stick with theta because it's what I have in my picture. Tangent of an unknown is still equal to our opposite over adjacent, but in this case I have 8 over 15. I don't have a denominator I need to get rid of. I have a trig function I have to get rid of. And here's where we're going to be introduced to something called arctangent. In order to get rid of sine, the inverse of it is the arcsine. The inverse of cosine is arccosine. And the inverse of tangent is arctangent. This is what they often look like in your calculator, so you will have another button that looks like this. Here is some variety, though. In the Google calculator, you have to hit the inverse button, and then those little -1 exponents will show up. In graphing calculators, you often have to hit the second button or the function button, and you'll see the arcsine or the arccosine above the original button. So you might see a button such as sine, and then in a different color writing, on my calculator it's blue, you'll see arcsine like this. And you'll know that you need to hit your second button to go to a second function. Sometimes these are written as arcsine or arccosine or arctangent. And that's going to be exactly the same thing. Just like anything else, the arctangent undoes the tangent function, but also like anything else, once you do it to one side, you have to do it to the other. So that's going to cancel out our tangent function and leave theta by itself. That's what we're looking for. The arctangent of 8 over 15 is 28.07 on and on. Remember, if you get something kind of weird here, you might not be in degree mode. Since I'd like to round things off to the tenths place, I'm going to keep this as 28.1 degree. That 7 is big, so it changes the 0. Now I need to remember that that means that 28 degrees goes up here. And that makes sense. It's kind of a smaller degree. This is a smaller side, so it's pretty reasonable. We're going to do one final problem to show you another example of how to find a missing degrees. Again, we're going to orient to that degree, even though it's missing, and we're going to figure out what we have. This is the hypotenuse, the side that's opposite our 90-degree angle. And this is opposite the degrees. So I have opposite. Since I have an opposite and a hypotenuse, that's going to let me use sine. Now, of course, our degree is missing. So I'm going to put theta here. Opposite over hypotenuse is 7 over 20. And I don't have anything over here to solve. I have to get rid of that sine function. So remember, to do that, we're going to multiply each side by the arc sine. I'm going to give myself a little bit of room on this side to do that. And then we'll plug this into our calculator. This tells us that theta is by itself, and the arc sine of 7 over 20 is 20.487 on and on. I'm going to round to tenths again. That 8 is big, so it's going to change the 4 to a 5. And I'm going to just check again for reasonableness. Again, it's here, so we're expecting it to be a small degrees. Don't forget to check out my description below, because I always have free worksheets that go along with this lesson exactly. Good luck, mathematicians.